Hi guys, today our lesson is the converse of the Pythagorean theorem, and it's actually a pretty well-used idea in construction. You can see this guy here is installing an egress window into his basement, and a really common problem in construction is trying to make sure that you get your right angles perfect. So here is what an actual construction worker might do. So once they'd probably obviously tape off the opening first, but the idea is that they would measure, and this is a 4 by 5 foot window. But what the measurement that they're really interested in is this diagonal right here, to see if that's actually a right triangle or not. And so the converse of the Pythagorean theorem says that, well, the original said that if you have a right triangle, then a squared plus b squared equals c squared. The converse says if a squared plus b squared equals c squared, then you have a right triangle. So we're just using the reverse to check. So we're going to see, does the 48 squared plus the 60 squared equal the 76 and 7/8 squared? If it does, then we're right on. If it doesn't, then we need to make an adjustment. So I'm typing in 48 squared plus 60 squared, and I get 5,904. Now how am I going to type in 76 and 7/8? One way to do it is just type in 7 divided by 8. 7 divided by 8 is 0.875. So if I take 76.875 squared, I get 5909.8. What does that tell us? It tells us that is not quite a right angle in there. So we'd want to do an adjustment. Now think about it. That 76 and 7/8 was a little bit too big, right? We had the 04 here, we had an 09 here. So if that was a little bit too big, what we would want to do is probably close these together a little more. Either bring this one, kind of bend it over a little bit, or bring this one and bend it up a little bit. But it's just a good way to check to see that you have a nice right angle. That's the idea behind the converse of the Pythagorean theorem. So here are some other examples, and we're supposed to decide, do we have a right triangle or not? The first thing you want to make sure of is that you have the biggest side that you're using for your hypotenuse. So what I just did is I typed in this 4 square roots of 3, and I got about 6.9. The only reason I typed that in is so that I could see that 8 was definitely my biggest number. And so if this is going to be a right triangle, the 8 is the hypotenuse. I want to check to see if that equals 8 squared. So I've got 16 plus, and you guys did a few of these on your assignment, 4 squared would be 16. The square root of 3 squared is 3. We want to see if that equals 64. So we take 16 plus 16 times 3, and we get 64, which equals 64. Tell whether a triangle with the given sides is a right triangle. Yes, we have a right triangle. So you would do the same thing for these other two. We would make sure that we had the biggest side. And if you remember yesterday, we were trying to figure out if that was a Pythagorean triple. Only we had 10, 11, and 15. And so let's see if 10, 11, and 14 would work. Because remember, the 15 wasn't quite right. So we've got 10 squared plus 11 squared, that was 100 plus 121, so 221. We want to see if that equals 14 squared, which is 196, and so that is a no way, not a right triangle. The last one, square root of 61. What's that going to be? I think it's bigger than 6, right? Because the square root of 36 would be 6, so that one's the biggest. So we'll use that for our c squared. We're checking to see if those are equal. The square root of 61 squared would just be 61. And we got another yes. We can actually take this one step further. I'm going to save this theorem for later, but let's look at this example. We just did this, but let's remember what we got. We got that our 10 squared plus our 11 squared, that was 221. And we were checking to see if that was equal to our 14 squared. And it wasn't. This was only 196. And so what I like to do, what we're going to do is we're going to actually figure out, we know that that's not a right angle. This picture is a lie. But what's happening? That hypotenuse, this hypotenuse imposter, it wasn't a hypotenuse, it's not even a right triangle, but that hypotenuse was too small to be an actual hypotenuse for the 221. I'm going to write that. Too small. And because it's too small, your triangle isn't going to look like this at all. What's going to happen is that 14 is actually shorter than it needs to be. So even if we keep this a 10 and we keep this an 11, the only way to make them connect is to move that in. And do you see what that did with my angle? Because that 14 wasn't big enough, my angle is actually acute, right? So that actually tells me that not only is it not a right triangle, if I look closely at the numbers, specifically the c squared, and it's too small, I can conclude that that's an acute triangle. Here's how that theorem goes. It says that if the a squared plus b squared is bigger than the c squared, then the triangle is acute, because that c would be too small. Sort of the other way is going to work too. If the c squared winds up being too big, see how the c is really long? Well, that's going to make the c angle bigger than 90, so it would be an obtuse triangle. So those are some theorems that go along with this. So if I gave you 3 lengths, you could tell me what kind of triangle it would make. The first thing I'd want you to do is figure out if you can actually even make a triangle using those lengths. Do you remember the old bridge problem? If our biggest one is a 6, are a 3 and a 4 big enough to even make a triangle? Would a 3 and a 4 fit across a 6? And I would say they would, because 3 plus 4 is 7, and that's enough to make it across a 6. So can they form a triangle? Yes. I didn't have to do any fancy squaring or anything. I was just doing that old bridge analogy to see if those 2 smaller ones could make it across the big one. And now if I ask you to classify by the angle, that's when you have to do the a squared plus b squared equals c squared, which probably doesn't equal c squared, but let's check. Does 25 equal 36? No. So we don't have a right angle, which maybe you could guess by my terrible picture, but that is not a 90-degree angle. What it is, and you can't always trust the picture, but look at that hypotenuse. This was supposed to be my hypotenuse, but it was not equal to 25. It was bigger. since my c squared was too big, that's going to open this angle up too wide to be a 90, and that's how we can tell that we've got an obtuse triangle. Good luck!